Now let's look at number 1B. Same situation set up as 1A. However, this time we're looking at 9 adult females instead of just 1. So in other words, we're going to look at if 9 adult females are randomly selected, find the probability that they have a mean. In other words, that mean from that sample overhead reach is greater than 204 centimeters. So again, we're not looking at an individual person, an individual female. We're looking at how does the mean from a sample of 9 adult females compare to other means of 9 adult females from the population. So we're going to look at the same 3 things again. We're going to look at shape, center, and spread. Now, first of all, shape. Notice here, n is equal to 9. We're only choosing 9 females. Now, normally we would say, then we can't do this, but up here, we said the original population was normally distributed bell-shaped and unimodal, so that means we can go ahead and work with this sample of 9. If we would not have said, if it would not have mentioned what the shape of the original population was, then unfortunately we would probably have to stop and we couldn't do this. You just say can't do. But since, even though this is less than 30, because we know the original population shape was normal, we can still go ahead and work with this. So the shape of our sampling distribution now, and that's what we're working with a sampling distribution where each sample is of size 9, and we're comparing the mean of that sampling distribution to other means from the population of size 9. So the shape would be normal. Again, why would it be normal? Because the original population shape was normal. Now, the center of this sampling distribution of females of size, samples of size 9, we are now looking at the mean of these sample means. Well, that's the same as the mean from the population, which is 205.5 centimeters. So again, sampling distribution, the mean of the sample means should be equal to population mean, which is 205.5 centimeters. Now here's where the change comes in. The standard error, we call this. Okay. That's equal to the population standard deviation divided by the square root of the sample size, because remember, larger samples make our distribution narrower. So our original population standard deviation was 8.6 centimeters. We're going to divide that by the square root of our sample size, which is 9. So basically it's 8.6 divided by 3. And you get then, and I'm going to go out to a couple decimal, about 3, 4, 5 decimal places. About 2.8666 centimeters would be the standard error or the standard deviation for this sampling distribution of sample means. I know that's a lot to have to say. So what we're going to do now is when we actually want to calculate and find the probability that that mean overhead reach was greater than 204 centimeters, we're going to use this value right here to do this. And we're going to use this. This is going to be, again, our mean that we're going to type into the computer, our stat app. That's going to be our mean we're going to use. That's going to be our standard deviation. So if I'm going to go ahead and do this. So if we go to, here we go. Again, we're just on the normal distribution. We're going to type in for our mean. That didn't change. And we're finding a probability. That is 205.5. Our standard deviation is 2.866. And then we want to know what's the probability that the sample means are greater than 204 inches. So we're going to go 204. And right here is what it should be, 69.96%. Now again, it's asking for a probability, so we'll have to change that over to a decimal between 0 and 1, but that's what we should have. So So the probability, make this a little bigger so you can see it. So the probability that the mean of a sample of 9 women is greater than 204 centimeters is equal to 0.6996, or about 70% of samples of size 9 would have an average height for women of greater than 204 centimeters.